Hello, this is Michael Osborne with Webucator. In this video, we're going to examine one possible approach to the problem of sorting strings using natural language rules. Now, this video is based on a blog post by Bradley Smith. Bradley agreed to let us create this video showing his solution, which is available as an article on his blog at the URL you see here. So let's begin by defining the problem that we're dealing with. When we talk about sorting, if we are sorting numeric values, for example, or date times, sorts are fairly straightforward. We know that 7 is greater than 4, and the 23rd of the month is more than the 17th of the month. So sorts are very simple. But what happens when we try to do a sort on an array of string values? We run into some problems. For example, suppose I declare an array, in this case a list, of type string, and into that list I add some values, for example 1, 4th inkwell, 10, 2, so forth and so on. How would I go about sorting these? Now, at first blush you could argue that, well, we can sort it alphabetically, but we probably will not get the result that we'd like. What I would like to see if I sort this would be first the term 0, then the value 1, the value 2, and then the third compass and the 4th inkwell and so forth. So this is the problem we're trying to deal with. How do we go about sorting these string values, essentially assigning numeric values to these strings in order to sort them in the way that we see fit? Now, as you're probably aware, the list class, the generic list class, includes a sort method. This sort method, if you call it, will use the default comparer for the type that's in the list, in this case string, so it would use essentially alphabetic comparison, which is really not the approach that we want. So what Bradley did was he defined a comparer class which we can pass to the sort method to control how these strings are compared. So what we're going to do is we're going to take a look at this comparer class, at how he defined these rules and how he implemented this special comparison process. So let's dive into some code. As we look at the natural language string comparer, the first thing that we need to examine is up here under nested types, and it's an enumeration. Now this enumeration is called match types. Now what's going to happen is this: as we parse these elements in the array into tokens, we're going to start assigning those tokens a value, an instance of this match type, which will represent what they are. So as we break this down, you'll see the first value in there is none. The value is 0, which means it's not a number. We could also assign the value digits, which means it's a sequence of digits, or word, which means it's a word with a numeric value like 3 or 4 or 7. We could also assign an ordinal word value, which means it has an ordinal value. So for example, 5th or 7th or 23rd or whatever. There is a and word or something equivalent to that, which is the value and then we have a flag that indicates that the numeric value can be added to an existing value, and another flag that says that the value can be multiplied by an existing value. So we're going to iterate through these tokens and assign them various instances of this match type enumeration. Okay, so now that we have a handle on this enumeration, let's go up and take a look at some static methods. So up here we have a collection of static methods. The first one in here is a Parse Natural, but before we get into that, I want to look at a couple of other pieces. First of all, you notice right at the top we declare a regular expression called sWordBreaker. We're going to use this regular expression to take an element of the array and parse it into separate tokens. So for example, if you have 3 or 4 different words separated by spaces, we would separate this into 3 or 4 separate tokens, which we will then iterate through and determine what they are. We also need to look at a couple little helper methods before we really tear into the Parse Natural. So let's scroll down here. First of all, I want to look at the should look ahead. Now the idea is this: we're looking at a string of tokens. So for example, the word 1, a space, the word 100, a space, and the word 30. Okay, so what it's going to do is its first should look ahead will check to see if that sequence begins with the word and or with an already parsable number, and if so, it will return false. And in other words, do not look ahead. We also have a should compare method. Now the should compare method basically is used to ignore the and at the start of a sequence. All right, then we have a should chain method. Should chain checks to see if we have already found an already parsable number, and if so, we need to stop looking ahead. All right. Then we've got the look ahead method. Now look ahead, a little more complex here. Essentially what look ahead does is this. We begin by declaring an instance of a stack of type decimal, and then we take the value that was passed in. This was a decimal value that was passed in, push it on the stack. We set our value to 0, and then we've got a little while loop. And we're checking the index plus the offset plus 2. While the index plus the offset plus 2 is less than the length of the words array. So we're looking basically 2 elements forward here so that we can skip over that space, that word break or whatever. And then we're going to parse again. We're going to declare a decimal called next value. Again, we will create an instance of match type and assign to it the result of this call to number, passing in the word, which basically will return an instance of that enumeration specifying whether that word is a number, a digit, whatever. Then we check if we should chain. If we should not chain, we will break. If we should chain, what we will do is then we will drop into this little try loop, and we will again increase the offset by 2. We will pop a value off the stack, put it into temp, and we'll check if the match type has flag modifier multiple. If so, then we'll say while temp equals 0, stack.any and stack peak get the next value. So we're basically going to pop another element off the stack until we get something that is non-zero. So the idea here is, again, we're handling terms like 100,000, okay, where we have 2 multipliers following each other. Then we're going to take those values that we pushed onto the stack, or I'm sorry, we're going to push them onto the stack, and then we're going to pop them off and basically add them up. We're going to do the multiplication to create our new value. Now, if the match type has flag match type modifier add rather than multiplier, what we will do is simply add the values together. So this is going to handle those complex ordinal word values that we might run into in the array. Now, the last little part of this method simply checks while stack.any, we're going to basically add the stack.pop to the value, and then ultimately, essentially what we've done here is we've added all those accumulated values together, and now we can simply return that value, return that offset, if you will. Okay, so we've got a few other little static methods to take a look at here. We have the static parse digits, parse word, parse ordinal, and toNumber. Now we saw toNumber earlier. Essentially what toNumber does is it will call these various parse methods, so parse digits and so forth, parse ordinal, and try to determine what the values are. So we're going to check to see if the string is a parsable number, if it's a word like 1 or 100, if it's an ordinal word like first or thousandth, and we're going to also take into account the words and so forth. We're going to have to deal with all of that. So let's take a look at each of these little methods. First of all, parse digits. Parse digits will declare a parsable string, and then it will check to see if the length is greater than 0. What it will do is it will trim the $sign from the start if there happens to be a $sign on the start. If then the char.isNumber parsable first, we're going to check to see if it ends with like an ST or ND, so first, second, third, fourth, so forth and so on. We're going to parse all that out, and then we're going to do a if decimal try parse. We're going to pass it the parsable, number style any, culture info, so forth. We will return true. In other words, we're saying yes, this is a value that can be parsed to a digit. In the parse word method, again, very similar. Essentially what we're doing is we're going through and we're using a little switch, and we're looking for certain values, certain word values. So we have 0, we have naught, we have 1, 2, 3, 4, 5, so forth. We've also got the various ordinal words, I think defined down in here somewhere. So there's like 13, 15, 18, 40, 50, 70, hundreds, billions, trillions. We've also got dollars, cents, so forth. So essentially what this guy does is it parses out that word and assigns to it a value, a numeric value for that word. Then we've got parse ordinal word. Now the job of parse ordinal is to look for things like first, second, third, fourth, 12th, 13th, 19th, and so forth. And again, in each case, it will assign or return a numeric value representing the numeric value of the word that represented. Okay, so now we've got all these static methods kind of broken down. Let's get back up here to kind of where we started and look at the parse natural method. What parse natural does is it will receive a string, it will receive a out parameter of type decimal called value, and a Boolean indicator $, which by default is false. It will declare an array of strings called words and assign to it this call to the S word breaker, that regex expression .split. So basically what we're doing is we're taking that string and splitting it into separate words. So basically we'll look for spaces and that sort of thing and split it up into separate words to build an array. Then we're going to iterate through that array. And for each element, or I'm sorry, each token within that array that we built, we will first of all check, we'll call that toNumber and see if this can be cast to a number or how to cast it to a number. And we will return from that a instance of match type that represents obviously what it is, whether it's digits or so forth. Then we'll check if we should compare the match type. Then we will increment I by a call to the look ahead method, passing in the words, the I, the ref value, and $. Then if should compare match type, we will return true. Okay. Otherwise, we will simply return false. All right, so now we've broken down all these static methods. The last piece of the puzzle here is the compare method. Be aware that this class is a comparer by virtue of the fact that it implements the iComparer interface of type generic, of type string, and the iComparer interface. So in other words, we must provide the implementation methods for those interfaces. So let's take a look at those. This is where it all ties together. Down here we have our implementation of the compare method. Now this is the just the compare method. It receives two strings, and basically what it does, it's checking a couple of Boolean flags. If M use natural language, if so, what we're going to do is we're going to split the array into the element into a couple of arrays, the X words and the Y words. We will then declare a couple of integers, a result, an X index, and a Y index, and we're going to loop through. We're going to do a little for loop for X index equals 0, Y index equals 0. While X index is less than the X word length and Y index is less than the Y word length, and then we'll increment X index and Y index. And what we do inside this little for loop, we declare a couple of decimals, the XN and YN. We then declare a couple of match types, XT and YT. We will parse the first number by calling toNumber, and then we'll check if we should look ahead. Then we will increment the X index by the look ahead X words, X index ref. Then we'll parse the second number, pretty much the same process. And then we check if we should compare XT and YT, we will compare them as decimals. Now, if they're not both decimals, we're going to have to kind of jump through some hoops. So the next thing we do is we check if we should compare just XT. In other words, if we're doing a mixed comparison, then what we're going to do is we're going to call the string compare class ordinal ignore case compare method, passing in the XN cast to a string and Y. Alternatively, if YT should compare, then we'll do the same thing, but in this case we'll use X and we'll use the YN.toString. Now, if none of those cases match, then our last option here is that they are strings. They are both strings, in which case we will do a string compare ordinal ignore case, passing in calling the compare, passing in the X and the Y. Now, if the result is not 0, we will return the result. Okay? If, however, we get through all that and the subarrays are equal, basically what we're going to do is we're going to figure out that the shortest one is the lesser value. In other words, they both contain the same value, maybe expressed different ways. We will assume the shorter one will be less. So we'll say the result is the X index compared to Y index, and if the result is not 0, we will return the result. And if that doesn't work, then our last option is to just drop back to the default logic. We'll just do a string compare, ordinal ignore case compare, passing in X and Y. So now we have our compare method. Now I want to point out we also have our implementation of the iCompare compare here, which is really nothing more than a call to the compare, which then converts the strings, both x and y, or converts x and y to string and calls the compare method that we just saw. So at this point, we built our compare class. Now all we have to do is put it to use. So let's go take a look at our main, our program here. And as you saw earlier, essentially what we do is we create an array, a list of type string called terms, and we load it up with various values. Some are decimal values, 1, 10, 2. Some are words like 103. We have some things like 7th saucepan and 4th inkwell, just all sorts of stuff in here. So the first thing we do once we build that list is we write out the values. So we're going to display a list of values. Then we're going to create an instance of our natural language string comparer, and then we will call the list objects sort method, and we're going to pass that comparer in. In other words, we're telling it use this comparer as you sort those elements. Then once it's completed the sort, we will again iterate through the elements and display them in the console to show you that in fact they were sorted. So let's give this a quick run, and you will see now that in fact we have sorted our terms. We start with 0, then we have the value 1 and 2, then we have 3rd compass and 4th inkwell and 5th pencil and 5, and so forth and so on. These have now been sorted according to the natural language rules as defined in our natural language string comparer. Okay, I'd like to again thank Bradley Smith for the inspiration for this video. Be sure and check out his blog at the URL you see here for some additional articles related to C#. That's it for this video. I hope you enjoyed it.